Hi everyone, in this video I'm going to just finish up our discussion on linear equations and their diagrams. So just all the end stuff that I didn't get to in parts 1 and 2. And in this video I'm going to start with the very general but very useful observation that to adequately describe a straight line you really need at the least 2 pieces of information. So for instance, if you just said I have a line and the slope is 2, that's just one bit of information. And well, if we think about an xy axis, that's true of an infinite number of straight lines. So, this line is a slope of 2 and this line as well, and this one, and any vertical shifts of any of these curves as well. So there's an infinite number of straight lines that have a slope of 2. But if we knew where our line intercepted either our y or x axes though, that would anchor our line appropriately. That would be a second piece of information that would allow us to describe our line. So say you also said, well, as well as the slope being equal to 2, and the y-axis intercept is equal to 2 as well. So we would then know the shape of the line exactly. That would be here. To give you another example, if I only had the x-axis intercept, so if you said, well, the x-axis intercept of my line is equal to -3, well, actually there are still an infinite number of straight lines of which that is true. So this one, this one, this one, this one. But if you told me, in addition to this, that the y-axis intercept was equal to -2, then that helps me, that allows me to anchor the shape of our line. So that's what it would look like. So we need 2 pieces of information at the least on our diagrams, and importantly, finding the 2 axes intercepts is one way that we can do that. So I'll talk about how to find our axes intercepts in a second. Before that, I will say, in the last video, I isolated the vertical axis intercept and the slope by using our slope-intercept form of the equation of our line. And we can actually use the lessons that I discussed in that video and the one before it to find the equation of this line when we have our 2 axes intercepts. So the equation of this line will be, we have y, that's the vertical axis variable, is equal to, we can find the slope, and I can just do rise over run here between our 2 intercepts. So starting from the bottom intercept, I can rise 2 and run backwards 3. So that would be, rise over run would be 2 divided by -3 times x, that's our horizontal axis variable, and then -2, that's our y-axis intercept. So that would be the equation of the line that I've drawn here. And you can look to the last couple of videos if there's anything that's not clear. But that's actually a nice application of some of the concepts that I spoke about in part 1 and part 2. In any case, this example gives us another way to draw our straight lines from our equations. We're going to isolate our 2 axes intercepts so we can draw our straight lines. Now, to understand how to find our intercepts though, just recall from our discussion regarding our Cartesian plane that on our plane here, and I'm just using an xy axis abstractly, each point or any point on this plane is described by 2 values, an x value and a y value, and that will give us our coordinates of any point. So I've put some up here. You can see any point can be described with an x and a y value. Now note then, if we're thinking about a line where it crosses, let's say, the y-axis, that point will correspond to an x value of 0. And likewise, if our line crosses the x-axis, that intercept will occur when y is equal to 0. So I hope you can see that. And it follows from that, let's do an example. If we have an equation, and I'll do an applied example, so I'll put price and quantity on our axes instead of x and y. And let's say we have the equation q is equal to 5 minus p over 2. To find the price axis intercept, so where our line passes through the price axis, that will be where q is equal to 0. So I'm going to, in my equation, set q is equal to 0 and then solve for the price. So just doing that, I get 0 is equal to 5 minus p over 2. If I add p over 2 to both sides, it removes it from the right-hand side but introduces it to the left. And I multiply both sides by 2 and I find the price is equal to 10 when q is equal to 0. So that's our price axis intercept. To find our quantity axis intercept, we're going to do the opposite thing. So we're going to set the price equal to 0 in our equation and solve for the quantity. So in our equation, substitute P is equal to 0. So we get Q is equal to 5 minus 0 over 2. So just 5. Once we have our two axes intercepts, that's our two pieces of information. We join those intercepts together and that will give us the shape of our line. Now, for those of you following the whole course and for those of you who have learnt a little bit of economics, you will note that we don't allow for negative prices or negative quantities. So we only work in this first quadrant. And so really this diagram looks like this. This is probably a demand curve. And if I was given the equation, I would only really draw the part where both price and quantity is positive. But we still have our two axes intercepts when we have demand, and so it is a great way to draw demand because often we're also required to label our axes intercepts anyway. And I suppose this does bring us to an important point though. If we have a supply equation, they often come through our axes like this or this. So we can't find two axes intercepts for these lines because there's only really one that's relevant for us. Now in this case, we could find the slope, which we have spoken about before, or we could, as another alternative, anchor our line to another point on our plane. And this is especially relevant if there is a point that is obviously a good candidate. For instance, if we had this equation here, Q is equal to P minus 1, so say it's a supply equation, and actually the price axis intercept for this equation is equal to 1. You can check for yourself at home. If we knew that the equilibrium price was 4, for instance, then we could just substitute P is equal to 4 into our equation and find that at the price of 4, the quantity is equal to 3. So that will give us another coordinate, another piece of information, which will allow us to anchor the shape of our line. So it would look like this. All right, so that's really drawing our lines from our equations. Now note that just the limiting cases, if the line is perfectly horizontal like this, it will only have a vertical axis intercept and it will be described by the equation. If we're just back at xy again, so y is equal to the intercept. So for instance, if we had y is equal to 5, that looks like this. And we're going to interpret this as x can change around and be any value, but y is always 5. Now, if a line is perfectly vertical, it will only have an x-axis intercept or a horizontal axis intercept. And it will be described as x is equal to the intercept. For instance, if we had x is equal to 8, that would look like this. And we interpret this as y can change around and be of any value, but x will stay constant at 8. And that's really it for linear equations, though. This is the last part. In the next video, I'm going to go through solving a system of two linear equations. So when we have two lines, we can solve for where they meet. Like for instance, if we have demand and supply and we want to solve for equilibrium. As always, thank you so much for watching my content. If you would like written notes to help you on your journey or even just to support this channel, to help me make more videos, you can visit my store. The notes include lots of practice questions with solutions, which can really help solidify your understanding of the skills discussed in these videos. Also, if these videos have helped, please like and subscribe, comment below, share all of that. It all helps. Any feedback is super welcome. Thank you so much, everyone, for watching my stuff. Have a great day, everyone.